Hello, I'm Mark Say from the Solutions Engineering team at Nuxeo in the UK. In this video, we will be looking at Nuxeo Vision. So firstly, we'll talk about what is Nuxeo Vision. We will look at how to install and configure the Nuxeo Vision module. Then we will build a studio project and implement a sample automation script, and then we'll finish off with a demonstration. So what is Nuxeo Vision? Well, it's a module for the Nuxeo platform that performs image analysis, detection, and recognition. We do this by leveraging cloud-based AI services such as Google Vision and Amazon Rekognition. Now, the call to these services can be implemented either automatically or manually. The automatic option could be as soon as we upload an image or a video. It could be triggered during the course of a workflow, or as a manual option, which we'll be performing in the demonstration at the end of this video. So Nuxeo Vision can be used to tag images with objects that can be identified in those images and videos, such as landmarks, brand logos, etc. We can also do face detection, such as sentiment analysis, like happy and sad. We can also do text extraction and OCR, or optical character recognition, to pull out the text and store that in our metadata. We can also filter inappropriate content in the case of Google Vision. They have their safe search method where we can categorize in 4 different categories, such as adult material, medical, spoof, and violence, and then a range of options from very unlikely through to very likely. There's other features that we can use, such as crop hints. We can do faces, emotions, headwear, and exposure. We can do some image property analysis, such as the dominant colors. And then a relatively new feature for Google Vision particularly is their web detection, where we can do matching of full or partially matching images that it knows about on the internet and some of the web pages that refer to those images. So during the course of this video, we have a number of tasks to perform to build our demonstration, and a couple of these are required in the Nuxeo platform. And then we have a few tasks that are in the Nuxeo Studio Modeler, and then a few more tasks in the Nuxeo Studio Designer. So we should go through these one by one. First off, in the Nuxeo platform, we need to install a couple of module packages, such as Nuxeo DAM and Nuxeo Vision. So Nuxeo DAM is the digital asset management module for the configuration layout of images and videos, and then the Nuxeo Vision module is the one we're interested in here, where we can call these external services. And for the course of this discussion, this video, and in the demonstration, we'll be using the Google Vision service rather than the Amazon Rekognition. Now, a small note, this latest feature for Google Vision, the web detection, is built into version 1.3 of the Nuxeo Vision package, which is available for Nuxeo platform version 10 and higher. I'm actually using the previous long-term support release version 2017, so I'm using a back-ported version of that package, and you can find some more information at the links below. So how do we configure Google Vision? Well, you must have a Google account. It's a paid service, so you must have billing enabled in your Google account, and then you create either an API key or a service account key, and you plug those values into your Nuxeo configuration file on your Nuxeo server. And there are examples for both those options there. Now, these keys are specific to you, and so they can't be shared. Again, links at the bottom for more information. Now we move into Nuxeo Studio, and in the modeler section, we go to the application definition, and we want to make sure that Nuxeo DAM package is installed in our Studio configuration. So in this case, we have Nuxeo DAM version 6.3.3 loaded into Studio. The second bit of configuration in Nuxeo Studio is to go to the external templates and make sure that we have the Nuxeo DAM configuration imported for the current version that we're using. And in this case, it's version 9.10, which is the long-term support release. And if you don't already have it, you can click the button there which says import this package. So we want to capture a lot of information from the Google Vision service, and we capture that into a custom metadata schema So we define that schema in the Studio Modeler under the schema section, and you can see the values that we're capturing here. So we're capturing the dominant colors. So this is a complex metadata property built of sub-values based on the alpha channel value, the blue, green, and red. We have a CSS string, and then we have a couple of other values that Google returns, the pixel fraction and the scoring. We're doing labeling and tagging, and this is again another complex property where we have the locale of the string and we have a scoring which gives us the ability to sort these labels in the order of relevance depending on how Google Vision is identifying those tags from the image that's supplied. We're also calling the safe search option. So this is another complex property where we have strings returned for the 4 different categories of adult, medical, spoof, and violence. And then we can optionally set a Boolean value depending on if any of these have likely content that's of sensitive nature. We can mark that as just marked for adults only, for instance. We'll also be doing some OCR analysis, text extraction, so we can store that in a text property. We'll also have a list of words for the individual words that are identified. We'll also be calling the web detection method. So we have a complex property for the web entities where we have an ID and a description and a scoring for each of those. And then as part of that web detection, we also have a list of fully matching images that exist on the internet or partially matching images, visually similar images at the bottom there. And we have a list of all the web pages which link to those relevant images. So that's all defined in the Vision schema. So we need to define a couple of facets. One is for in the document types, we're extending the type service with an XML extension that goes into this section of the Studio Modeler configuration. And here we're defining 2 facets. One is called attachable, which links the file schema. So this is a schema which is defined in the core platform, but is not actually linked to picture images. So we will display these for picture images in a subsequent configuration, but we'll define the facet here. And the second one is the visionable schema, where we're just linking that to the Vision schema, which we've just defined. We also need to load these into the Studio registries. So we define some JSON configuration, which links the ID of these facets with the schemas in the JSON syntax there. So when we configure the Nuxeo Vision module, it comes with a default event handler, which by default, when you create a new image, it will automatically upload that image to Google Vision and perform some tagging. So we're going to build our own. So we're just going to disable the default event listener here. And we do that with another XML extension to the event service component. And you see that we have 2 listeners here, one for pictures and one for videos. So we're just going to disable both of those and build our own. And this is taken straight from the documentation where the link is at the bottom there. Next up, we're going to create an automation script. So in Studio Modeler, we go to the configuration automation scripting section, and we define a new script. In this case, we're calling it Vision Response _JS. And the input output types for these are document and documents. We'll be operating on a single document at a time. And the general synopsis is that we're calling the core operation from the Nuxeo Vision module, which is the Vision op. Now this takes 3 parameters, which is, the first is a list of features, for example, text detection, or it could be label detection, or it could be image properties, or safe search, web detection, for instance. We specify a maximum number of results that we want to return from those services. And then we specify an output variable name in the context that we store the response so that our automation script can pull those values back. And then generally in the script, yes, we want to pull those values out of the response from the Google Vision callback. And then we put those values into the Vision schema, which we previously defined, including the dominant colors, tags, OCR text, and web entities, for instance. Now, an example script is a fairly basic one here, which is just doing tagging. So let's see how this works. So we specify our standard run function, with our input and parameters. And then the first thing we do is get the blob, which is our file content, which is our main file that's attached to this document. Now, there is a file size limit for uploading images to Google Vision. So we need to make sure that if we're larger than that limit, we're going to get the medium view rendition of that image. In this case, we're only going to call one feature, which is the label detection. So we specify our vision operation here, and we pass the name of the blob, the reference to the blob, and then the features that we want. So there's that label detection, 50 results, and then we're going to store the output into this context variable called vision responses. So when we call this vision op, we always get a list of vision response back. So we've only got one image we're dealing with in this case, so we're just going to get the first one in the list here. And then we're going to call the API call here, which is to get classification labels. And then we just loop through those, substitute spaces for pluses because we can't have spaces in tags. And then we're going to call the tag document with a list of tags and then just return the result. So get the blob that we want, call the vision op, get the classification labels, tag the document, and then we're done. So a fairly simple automation script calling the Google Vision or the Nuxeo Vision wrapper for Google Vision in this case. On the user interface side, we're going to translate the user interface. So we specify our localization messages here, and I'm just dealing with English here. So we have our label definitions and then the actual text that we want to supply. And this all goes into the messages.json file in Studio Designer. So in this case, we're also using a couple of custom elements. Now, the first of these, the Nuxeo SE collapse, is a collapsible HTML div element. We shall see this in the demonstration. The second custom element is a document operation action, which is a custom operation button that fires events when the execution of the operation that we specify, when that finishes, we can fire some events. We shall see this in operation 2. So we also define a layout for our custom vision schema based on the number of properties that we have. This is reasonably complex, so I don't have the full listing here, but we shall see the output of this in the demonstration. We're also defining a custom action button. So this goes into the Nuxeo project bundle file, and the project is based on your studio project name. So we're importing our custom element here, which is document operation action. And then in the slot content, in the document actions, we're specifying a new document operation action, which calls Nuxeo Vision. And then the key one there is the operation is the JavaScript vision response underscore JS, which we previously defined. So for pictures, as I mentioned, by default, pictures don't have attachments. Standard file objects show the document attachments, but pictures by default don't. So we need to add the attachments into the picture view layout, which is why we created a facet for this purpose. So the sections with a highlighted background here are the bits that we've added into this, into the standard layout file. We have some styling there for Nuxeo document attachments. And then we're calling a template here that says, if we actually have this attachable facet, then we display the relevant element to display those, the links in the UI. And then within the polymer section, we define our custom function here, which has facet, which is based on the document itself and the facet that we're passing in. We're also going to modify the picture document page. So we're going to say that with a picture, again, if the document has the particular facet visionable, i.e. that we've called the Nuxeo Vision operation and we've imported data into the vision schema, that we actually want to display our custom layout, the Nuxeo SE schema vision view, that we want to call this if that facet exists. So we're modifying this picture document page based on that information. And now onto the demonstration. So I am going to log in as administrator. And I'll go to a folder that I've previously defined just for the purpose of demonstrating the Nuxeo Vision. So here I have an empty folder. Here on the right in my Windows Explorer, I have a JPEG file, and I'm going to drag and drop that in and just create it by default. So while it's rendering that preview there, we can scroll down and we can see the different cards. If I just refresh that, there's the preview of the image. You see it's actually a scene from New York, which is some road signs, a bridge and tunnels, and a vehicle going through. But in the different cards that we have at the bottom here, we have the picture information, which shows the dimensions and the format of the picture. We have the additional renditions that have been created, all as part of the standard Nuxeo DAM configuration. And then we have these two cards here. One is the EXIF information, where we've extracted image metadata from the file itself, and we're displaying that, such as the camera information, such as the aperture and exposure. And then we have the IPTC card here, where it exposes the copyright information, the rights, the source, and the description of the photo as well. You'll notice in the tag section that we currently have no tags, and we just have a basic title. So this is standard operation. From here, we're going to call the Nuxeo Vision operation and extract all that information from the external service. So we're going to call Google Vision in this case. So you can see I have a custom action button here, which is Nuxeo Vision. So I can click on that. We get a pop-up message saying we're extracting the image metadata. And when that's complete, the page refreshes, and then you'll see that we have a number of tags here. So we've got parking, city, sign, etc. So these are tags that Google Vision has identified from this scene, such as city sign, street signs, infrastructure, car, urban area, lanes, etc. Now, if we scroll down below that, we have the Nuxeo Vision card. So this is based on our view layout that we've configured, is that we now have the vision schema or the vision facet attached to this document, and we can now view the schema metadata that we've extracted from the image. So first up is the dominant colors. So you can see from the scenery here, there's a lot of green and then lots of browns and grays. So these are the colors that are identified by Google Vision. And you can see these little arrows here. This is the collapsible div. That's one of the custom elements that we implemented to control how much information we're displaying on the screen at one time. So after the dominant colors, we have the labels. So you can see we've got 16 different labels here. So these are the same as the tags that we have up here. But as I mentioned, when we're storing the labels, we actually have a scoring value. And if I hover over one of these, you can see the score is 95.9% there. So that's the predominant label that it's identified, all the way down to advertising, which is 50.5%. So that's just with a little tooltip pop-up. So moving on down, we have the optical character recognition. So we have 26 words that have been identified, and we see these as separate words. So this is what day one of retirement looks like in New York, plus the road signs here. So if we scroll up to the image, that's identified that information, that text from that small advertisement on the wall up there, which is quite small, difficult to see by the human eye, but doesn't escape the OCR detection. And then we have the road signs, and then we actually have a phone number on the back of this van, which is the last tag at the end there. So we have those 26 different words, and we also get them back as a full single string, so 137 different characters in a single string with formatting, as you can see there. Moving on down, we have the safe search. So we have those categories, the 4 categories, and based on the image in the picture, the image that we've uploaded, it's categorized these as very unlikely to include any adult or sensitive material. So it's marked those as very unlikely. So we also have 13 different web entities that's identified. This is very similar to the labeling and tagging, but it's more about entities that Google, in this case, knows about, such as traffic signs, traffic, direction, position, or indication sign, for instance, well, and identifies these, again, with a scoring and a unique ID for each of these. As you can see, it's identified that this is New York City, rather than based on its context and the information which it's identified in the image. It's pretty sure this is New York City, so that's using its artificial intelligence algorithms to identify those entities. So we can see we've got no fully matching images on the internet. In fact, the image that I'm using is a cropped picture. So we do have some partially matching images. You can see some examples there. And if I open these up into new tabs, I think that's just a download, that one. Let's open up the second, third, and fourth. So you can see in the second one there's a full-size image. It's like a 4:3 image rather than a widescreen image. And then we have a smaller rendition of that and a different version as well. So you can see these are partially matching images that it's found on the internet. And then we have visually similar images, which are kind of similar road signs, but of a different place. And then we have the pages that those matching images are called from. So I can open up one of these, for instance. So you can see there's the image in this case from this URL. So this is the Google Vision web detection, identifying these entities and matching images and matching pages on the internet. Now, we did some OCR analysis and we looked at the values output of those. In this case, I've also saved that output text as a separate attachment. So this is the reason we had the attachable facet, which we defined, and we're displaying for pictures. So we have that separate attachment, and I can preview that attachment. There we are, and that's the same text. This is what day one of retirement looks like in New York. There's the road sign information and then the phone number on the back of the van. And in this case, I've just put a date stamp on there as well, so we know when that information was captured. So that pretty much concludes the demonstration. If we just go back to the slides and follow up here. So this is a summary screen. There we have the image uploaded. On the right-hand side, we have the display of all the image that we've captured using Nuxeo Vision, the dominant colors, the labels, the OCR text, the safe search, the web entities, and the matching and partially and fully matching images, and the reference pages. And that OCR text has been identified from the small advertisement on the wall at the back, the 3 different road signs, and then the phone number on the back of the van as it's driving through the tunnel. And then we've extracted that also into a separate blob attachment. And there, that's just a representation of the preview of that blob as we're looking at it. And those are the 3 different sections. And we'll finish off with just a reference page where you can find some more information about the Nuxeo Vision service. We have some documentation. There's the package on the Nuxeo Marketplace if you want to get started for yourself. Information on the integration with Google Vision and Amazon Recognition. We have the GitHub project if you're interested in looking at the source for how it works. And then we have some blog posts talking about some different capabilities for safe search, OCR, and then one with Amazon Recognition in particular. And then we have the information on Nuxeo University if you want some learning course material, and then documentation around the Google Cloud Vision API. So this just wraps up this video about Nuxeo Vision. I hope you found it useful. Thank you.